So let's have a quick intro to set theory. So a set is a well-defined collection of objects, and entries of a set are called elements or members of the set. Yeah. So we use capital letters to denote a set and small letters to denote elements of a set. Yeah. So if you have something like this, it means A is an element of the set S. And we said earlier that we use small letters to denote elements of a set, and we use capital letters to denote the set itself. Yeah. So if you also have something like this, it means A and B are elements of the set S. So this symbol, as we have used earlier on, means it's an element of. And when we cancel the symbol, it means it is not an element of. So let's go to cardinality of set. Yeah, so to find cardinality, you count the elements in a set, then the result you have, that's cardinality of the set. So for set A, we have set A having elements being 1, 2, 5, 7, 11, and 12. So we count the elements in set A. So 1, 2, 3, 4, 5, 6. So cardinality of set A is 6. Let's move on to cardinality of set B. So with set B, it has no elements. Hence, cardinality is null. Yeah. So when a set has no elements, cardinality is null. For set C, cardinality is 1, 2, 3, 4, 5. It has 5 elements, so cardinality is 5. You just count the elements in set C to find the cardinality. And in set D, cardinality is 7 because D has 7 elements. 1, 2, 3, 4, 5, 6, 7. Yeah. So that's how you find cardinality of set. Let's take some point to understand some terms in set. So if we say subset of a set, so let's say over here we say B is a subset of A. This is a symbol of subset. So if we say B is a subset of A, we are being given this. So A has elements 1, 2, 3, 4, and 5, and B has elements 2 and 4. So we are saying that A is the subset. We are saying B is a subset of A, which means that every element is in B is in A. So I'm taking elements in the set B. We have 2 and 4. So to say B is a subset of A, we should have 2 and 4 in A. So when you check A, we also have 2 and 4. So hence we can say B is a subset of A. Let's move on to equality of a set. So if we say a set A is equal to a set B, it means A is a subset of B and B is a subset of A. Meaning every element in A should be found in B and every element in B should be found in A. Yeah, so there is an example here. We have A being 1, 2, 3 as its element, and we have B having 3, 2, 1 as its element. So both sets contain exactly the same elements, just that the order changes. Let's find the order. So far as we are achieving the point that A is a subset of B and B is a subset of A, it means A is equal to B. So that's the explanation for equality of a set. Point three. So Cartesian product of a set. So if you see something like A times B, it means Cartesian product involving set A and set B. Yeah. So we combine the elements in set A with the elements in set B using other tests. Yeah. So there is an example where we have A having elements 1 and 2 and B having elements A and B. Yeah. So as I said earlier, Cartesian product, when they say find Cartesian product of A and B, you write A times B. Yeah, then you find the other pairs. Other pairs are in such a way that you take one and combine it with A. Then you put it into brackets. Then you combine one with B. When you're done, you combine two with A, then two with B. Yeah. So in other pairs, you make sure that you take an element in A and an element in B. Then you group it, putting them into brackets to form your new set, which became Cartesian products of that set here. So to find Cartesian products of A and B, this is how you do. You take A, kind of combine, you take one, kind of combine it with A from B. You take one from A, kind of combine it with B from B. Yeah. Then you take two from A, kind of combine it with A from B. Two from A, kind of combine it with B from B. Yeah. So let's move on to set complement. So if you see A raised to the power C, it means A complement. And elements that are not in A but are in a universal set is what is A complement. So if you have a universal set, denoted as U, capital U, having 1, 2, 3, 4, 5, 6. Yeah, and A has 1, 2, 3. To find A complement, you just find the elements that are not in A but are in the universal set. So the elements that are in A is 1, 2, 3. The elements that are not in A but are in the universal set are 4, 5, and 6. So that's how we find complement of a set. So A complement will be 4, 5, and 6. Let's move on to point five and point six. So point five, we are talking about union of sets. So if we say find A union B, you have to just combine all elements in both A and B. And whilst combining the elements in A and B, and you see an element repeating twice. So let's say we are combining A and B. A has 1, 2, 3, and B has 3, 4, 5. Three repeats twice, and you have to combine the elements. In combining, you just repeat three once. Yeah. So let's combine A and B. So this is how you do it. You write A. You write your A element. So you write 1, 2, 3. Then 3 comes again, but you write 3 once. Then you write 4, and you write 5. Yeah. And in doing the combination, always try and make sure it is in ascending order. Yeah. So try and make sure that when finding A union B, you are writing the elements that make up A union B or any union combination. Try and make sure the elements are in ascending order. Yeah. So point six, intersection of sets. Yeah, we have to find A intersection B. This is a symbol for intersection here. So I mean finding A intersection B, you have to find the elements common in both sets. So the elements that are in A and also in B. Yeah. So we have A being 1, 2, 3, 4, and we have B being 3, 4, 5. Yeah. So you check the elements that are both in A and B. So when you take A and B, the elements that are both in A is 3. So 3 is in A, 3 is in B, and 4 is in A, 4 is in B. So A intersection B will be 3 and 4. Yeah. So that's how we find intersection. Let's move on to point 7. So we have to find set difference. So set difference is denoted by A backslash B or A minus B. Yeah. And in finding set difference, we find the elements that are in A and not in B. So if we have A being 1, 2, 3, and 4, and B being 3 and 4, we find elements that are in A but not in B. So which elements are in A and not in B? We find out that we have 1, 2, which are in A, but you can't find them in B. Yeah. So the set difference of A and B will be it will be 1 comma 2. Yeah, because 1 and 2 can be found in A but cannot be found in B. Yeah. So 8, symmetric difference. Symmetric difference is denoted by the triangle symbol. Yeah. So if they say find symmetric difference you can of A and B, you can write it as A triangle B. Yeah. So in doing so, we find the elements in either A or B, but not in their intersection. But simply we use the formula. So if you have to find the symmetric difference of AB, you write A triangle B being equal to the set difference of AB union the set difference of BA. Yeah. So you find elements that are in A but not in B union elements that are in B and not in A. Yeah. So we have an example here. We have A being A, B, C, K, P, Q, R, S. And we have B being B, K, Q, M, N, O, T. Yeah. So we find elements that are in A and not in B. When you find it, you get, which is this, denoted by A backward slash B. You find when you find it, you get A, C, P, R, and S. Yeah. So A, C, P, R, and S. You can find them in A, C, P, R, and S, but you can't find them in B. Yeah. So when you are done, you also find elements in B that cannot be found in A, which is denoted by A backslash, which is denoted by B backslash A. Yeah. So in doing so, when you have to find the elements that are in B but not found in A, you get M, N, O, T. M, N, O, T can be found in B, so M, N, O, T, but they cannot be found in A. Yeah. So when you are done, you combine the two to form union. Yeah. So you combine elements in what you found in A backslash B and B backslash A. Yeah. To get your A triangle B. And I said A triangle B is also called symmetric difference of A and B. Yeah, so that's how we go about finding symmetric difference. Let's move on to point 9, which is power set. So power set is denoted by P into bracket, then you break the set given. So in this case, the set is A. Then you put P into bracket, A into strokes. And the formula we use to find power set is 2 raised to the power n, where this n is the number of elements of the set given, this time A. Yeah. So the aim is to find the set of all possible subsets of the given set, including empty and the set itself. Yeah. So to find power set, we write of A. So A has elements 1 and 2. So which means n will be 2. So the number of elements of A is 2. 1, 2. Yeah. So to find power set, you just put P into bracket A, then you put it in strokes, equals 2 raised to the power n. We know n is 2, so it will become 2 raised to the power 2, which should give us 4. Yeah. So if you want to list all the possible subsets of A, which is the set A, we have our first element being the empty set, then you bring 1, the next one is 2, then you bring 1 and 2. Yeah. But in listing them, make sure you put them in curly brackets. Yeah. That's how we write the list of all possible subsets. Yeah. Let's move on to 10. So finite set. A finite set is a set that has a fixed or defined number of elements. Yeah. So let's take the set A. A has 4 elements. 1, 2, 3, 4. Yeah. So the number of elements is 1, 2, 3, 4. Yes. So since we can determine the number of elements A has, it means A is finite here. So let's take B2. B has 3 elements, so A, B, C. So the number of elements is 3. So since we can determine the number of elements of B, it's a finite set. If you have an element that you cannot determine the number of elements of that, if you have a set that you cannot determine the number of elements of that set is not a finite set. It's an infinite set.